So now we're going to take a look at absolute value, and then we're going to extend that discussion into absolute value inequalities. Now, you may remember from Algebra 1 and even far as back as pre-algebra that absolute value, the operation, ends up giving us a positive value no matter what is grouped inside the absolute value symbol. This is a result because absolute value by definition is the distance that point is from 0 on the number line, and if you recall from geometry, distance cannot be a negative value. So absolute value equations are equations that have the variable within inside the grouping symbol of the absolute value bars. And since we know that the distance can be on either side of the value of 0, we are going to have two possible solutions for absolute value equations. So if you look at the given equation in the first graphic here, we have the absolute value of x equals to 5. Well, we know that that could either be at a positive 5 units or a negative 5 units. Those are both a total of 5 units away from 0, and so it has two given solutions. Now, occasionally you'll get one where there are no solutions to the given inequality, or absolute value, and so we may say that that a solution is extraneous, and we'll discuss this a little bit further in class. But an extraneous solution is a solution that you get from an original equation, but it does not actually make the statement a true statement. So we'll discuss that more as the year goes on. Now let's take a look at the three basic possibilities here with absolute value. If we're dealing with an equal sign, what you need to remember is it creates a compound statement here. And so basically an equal sign is going to give you an or statement. And so we create that or statement because we're basically going to take the expression out of the absolute value and make it equal to what it was originally. But then we're also going to make it equal to the negative version. And so that gives you the two statements necessary. And in this particular case, since we're dealing with equations, we have two very distinct points on the number line. In this case, -2 and a +3. But the one thing that you need to remember specifically is what the or statement, an equal sign creates an or statement, and so both of them could be solutions. Okay, so let's extend this conversation to absolute value inequalities. So if we're now look at absolute value inequalities, we need to make a distinction between the types of compound inequalities that we're going to be dealing with. And so if we are looking at an absolute value inequality that is a less than symbol, so less than symbols create an and statement. And then you can see on the number line in this graphic that creates a range-bound set of solutions. In this case, from -3 to +3, all those are within or less than 3 units away from the given point of 0. So first thing you want to be sure you remember is less than is an and compound inequality. If we look at the or statements, you can see that a greater than symbol, so the greater than symbol is going to give us an or statement as well. So we have equal signs that will give us an or statement, and we have greater than will also give us an or statement. And so all values greater than 5 units away from 0 would be graphed in the graphic that you see right there on your screen. Now, we give you a summary of all of these parts with absolute value inequalities along with their interval notation. So you would definitely want to pay close attention to that. So we have a sample problem number 4 down here. Go ahead and take a look at those, pause the video and work through that, and then come back and check your solutions here in a second. Okay, so the first one gives us an absolute value statement that is less than. So I know that that's going to be an and statement, and I can write an and statement inequality as a collapsed form. So I'm going to do that. I know that the 3x plus 2 is going to be less than the original 7, but it's also going to be greater than -7. Now I could have broken that up into two completely different steps, two separate simple inequalities, but I've decided to keep it together in one collapsed form and then work my way through it this way. So I'm going to subtract 2 from both sides, and then I'm going to divide all parts. by 3. And then I'm going to go ahead and graph that on a number line. And so basically from -3 to a positive 5/3, I'm going to graph everything in between there. And of course, since it's not equal to those actual points, I use the open brackets and I shade everything in between. Okay, so that is your basic AND statement. So keep that in mind. That's an AND statement. Now the one in part B is greater than or equal to this time, and so this is an OR statement. So I need to set up two separate inequalities. The first one, I'm just going to take the expression out of the absolute value and set up my first inequality. Or we can have that same expression and we're going to reverse the inequality this time. It's going to be less than or equal to -2. And then I would want to solve both of those individually. If we subtract 4 from both sides and then we divide both sides by -1, that is actually going to flip our inequality. And then we'll do the same thing over here. And then lastly, we want to graph this absolute value inequality. And since they're both equal to, I'm going to use close brackets, and then I'll just go ahead and shade the part of the number line to infinity. And there is our compound inequality with an OR statement from absolute value inequality. Okay, and that is a quick reintroduction to inequality statements and absolute values. This should be a nice review from what you learned back in Algebra 1.